Last time I computed the limit by using the limit law, and I told you that the technique of computing the limit using the limit law involving algebra, that you're gonna have to be able to factor, you're gonna have to be able to get rid of the square root. The next technique for computing the limit is called the left-right limit. We learned before that when we have the limit on the left. Okay, so let me just write this one down. So you have the limit x go to a from the left of fx equal to limit x go to a from the right of fx. This one will imply that this one will be even only if limit x go to a of fx exists and this guy equal to the real number L. So if we have the left limit equal to the right limit, we'll be able to conclude that the limit at that point equal to the number L that you have. Okay, so this technique is called the left-right limit. Now we gonna compute the limit by using this technique. So you have fx equal to x squared minus 3x minus 10 over absolute x plus 2 if x not equal to negative 2. So we have to simplify this guy a little bit. So you have fx equal to x squared minus 3x minus 10 over over uh, absolute x plus 2. So we learned before about the absolute value, that absolute value turned out to be itself. Okay, so absolute value of triangle turned out to be triangle if triangle is positive, and it's going to be negative triangle if the triangle is negative. Okay, so in this case, the absolute value that you have here is absolute value of x plus 2. So this guy, you see that you'll be able to factor the top guy. So it's going to be x plus 2, x minus 5, and this guy is over x plus 2. Okay, so if you have x plus 2 is positive, it cannot be 0 because it's on the denominator. And you have x plus 2, x minus 5 over negative of x plus 2 if you have x plus 2 negative. So for this one, you see that this guy is the yellow guy. Okay, so you have two cases of the yellow guy according to positive or negative. Okay, and you're gonna be able to simplify this one. So you see that you'll be able to get rid of x plus 2 and x plus 2, x plus 2 and x plus 2. So it's gonna turn out to be x minus 5 if you have x more than negative 2 and you have negative of x minus 5 if you have x less than negative 2. Okay, so this is your fx, and then you're gonna find the left limit. So you have limit x go to negative 2 from the right of fx. When you have limit x go to negative 2 from the right of fx, this guy means you have x more than negative 2. Okay, when you have x more than negative 2, you are in the first case. So you are in the case that x is more than negative 2. So you get x minus 5. So you would get limit x go to negative 2 from the right of x minus 5. Okay, and this guy, okay, so I'm gonna highlight the orange one, and it's gonna turn out to be equal to negative 2 minus 5 equal to negative 7. So this is how we get this limit. And you're gonna have limit x go to negative 2 from the left of fx equal to limit x go to negative 2 from the left of negative x minus 5. Okay, and this guy turned out to be negative of negative 2 minus 5 equal to 7. So you see that these two numbers are not the same. So you have limit from the left not equal to the limit from the right side. So this guy is the pink one indicate the the left limit. And this one, you are in the case that x less than negative 2. So you have the left limit equal to 7, the right limit equal to negative 7. So in this case, you're gonna conclude that the limit x go to 2 of fx does not exist. Limit x go to 2, not 2, to negative 2 of fx does not exist. Okay, so this is how we do this one. So you have left limit not equal to right limit, and you'll be able to get the limit does not exist. Okay, so this one, the way to deal with this limit. Okay, so the way to deal with this limit, let me write this one a little bit clearer. So this one, the question asks you to find the limit of x squared minus 3x minus 10 over absolute value of x plus 2 does not exist. Okay, so you have left not equal to right, and you have this limit does not exist. You see the thing that we do left limit and right limit because of what? Because we see absolute value. When we have to deal with absolute value, the technique of finding the limit, not factoring. Factoring is not going to help us because if you just factor, on top you get x plus 2, on the bottom you still have absolute x plus 2. They not cancel. Okay, so let me write something like this to warn you a little bit. When you have x plus 2 over absolute x plus 2, they not cancel each other. So you not be able to do this. It's not cancel each other. Okay, so this guy not equal to 1. Okay, so this guy not the same, so it's not equal to 1. So you not be able to just cancel the limit and obtain the solution. Okay, so this one will be limit does not exist by showing that the right limit equal to negative 7 and the left limit equal to 7, that they're not the same. Okay, the next one, you have fx equal to 2 minus x squared, and when x more than 1, and you have x minus 1 over 2 when x less than or equal to 1. The question asks you about continuity. The question asks you that is f is continuous at x equal to 1 and asks you to explain. So this function in math is called piecewise function. Okay, so this guy is called piecewise function. It means that you have two formula or more for your function. And you have the yellow formula and you have the blue formula for this function. And you're gonna find the limit from the left and the limit from the right side to see whether they are the same. Okay, that for the limit of fx. So in this case, you're gonna compute limit x go to 1 from the left of fx, and you're gonna compute limit x go to 1 from the right of fx. When you are dealing with x go to 1 from the right, from the left, this thing means that you have x smaller than 1. Okay, so when you are having x smaller than 1, it's gonna be in the blue color. Okay, so you are in the blue color. So you're gonna have limit x go to 1 from the left of x minus 1 over 2, and it's gonna be 1 minus 1 over 2 equal to 0. And you are having limit x go to 1 from the right of fx. So in this case, you have x more than 1, and this one you are in the case of the yellow color. Okay, so you have in the case of the yellow one. So in this case, you're gonna have limit x go to 1 from the right of 2 minus x squared. Okay, and you're gonna just plug in, so you get 2 minus 1 square, and it's gonna turn out to be 1. And you see that the left limit not equal to the right limit. Okay, so the left limit does not equal to the right limit, so you have 0 not equal to 1. So we're gonna conclude that limit x go to 1 from the left, not from the left, of fx does not exist. Okay, so you have limit x go to 1 from of fx does not exist. And so you're going to be able to conclude that fx นะครับ the function f is not continuous at x equal to 1. The thing that you be able to write something like this down, however, what does it mean? It means that if you are seeing 1 in the middle like this, you know that when you are approach 1 in this direction, when you are approach 1 in this direction, the graph of the function turn out to be approach 0. Okay, so it's gonna turn out to be approach 0. I don't know what is the graph look like, but I know that the graph will be like this. Okay, so it's gonna be like this, and I have the y-axis here, and this one is your x-axis. Okay, and you're gonna have the left limit equal to the right limit equal to the left limit equal to 0 and the right limit equal to 1. So the picture will be like this. And you see that f0, if I ask you about f0, you're gonna plug into the second formula, because you are not f0, f1. If you are asking for f1, you're gonna plug it into the second formula, and you're gonna get 1 minus 1 over 2 equal to 0. So in this case, you have f1 equal to 0 like this. And you see that you have the left limit approaches 0, the right limit approaches 1. So you see that this one not equal to is going to give you the thing that we have seen before. It's going to give you a jump. So you're going to have a jump between the function. So you have the jump from left to right like this, and you're going to say that, oh, this one you have a jump here, so not continuous. Okay, so you have not continuous. Okay, so you have it's not continuous function. So the difference here, okay, so we're gonna do another one. So you have f is not continuous at x equal to 1, and in this case, the left limit not equal to the right limit. The behavior of the function turned out to be a jump. The next one, you see you have fx equal to square root of 1 plus x squared when x more than 0. So this one is the yellow case. And the second one, you have fx equal to negative 2 plus 3 over x minus 1 if x less than or equal to 0. So this one is the blue case. The question asks you the same thing but at 0. So the question asks you whether it's continuous at 0. So you're gonna find f0 first. Okay, so the easiest thing would be just finding f0 to see whether you have a hole or not. f0, you're gonna plug into this formula. So it's gonna be negative 2 plus 3 over absolute x minus 1. So it's gonna be absolute 0, 3 over absolute 0 minus 1. Okay, so you get negative 2 plus 3 equal to 1. Okay, so you have f0 equal to 1. And now I will compute limit x go to 0 from the left of fx and limit x go to 0 from the right of fx. So in this case, you see that you are having the yellow case down here, okay, and you have the blue case up here, okay. So I'm gonna find limit x go to 0 from the left of negative 2 plus 3 over absolute x minus 1. So it's going to be negative 2 plus 3 over absolute 0 minus 1. So it's going to be negative 2 plus 3 equal to 1. And you have limit x go to 0 from the right of fx with the yellow case. So it's going to be 1 plus x squared. And this guy turned out to be square root 1 plus 0 square. So it's going to be root 1 equal to 1. So in this case, you're going to see that they are the same thing. Okay. And we're going to be able to conclude that limit x go to 0 of fx equal to 1. Okay, and you have f0 equal to 1 also. Okay, so you see that these two numbers are the same. Okay, so they both equal to each other. So in this case, it's going to be no jump, no hole. So the condition, the conclusion here will be f is continuous at x equal to 1. Okay, so you have f is continuous at x equal to 1. Okay, so this one is for number 3. For number 4, you have limit x go to negative 1 of absolute x plus x squared minus 2 over x plus 1. So in this case, you see many absolute value. Okay, so you have absolute value and you have another absolute value here. Let me use another color. Okay. And you see the problem. The problem will be we like to find limit x go to negative 1. So you're gonna draw the picture that you are having -1 in the middle. Okay, so you have -1 in the middle, and you're gonna have -1 here and -1 here. Okay, and you are seeing that if you have x equal to -1 like this, you like to work with the number that allow -1 close to -1 on both sides. Okay, so it's not gonna be far from -1. Let me scale you a little bit that y equal x equal to 0 is here. Okay, so you see that it's gonna be not far from -1. You're gonna like to find the number that kind of near -1 that I used to tell you about what this is called really close. Okay, so it's gonna be the number that very near -1, and you're gonna try to uh, take off the absolute value. In order to take off the absolute value, you may have to separate cases. And the problem on taking off absolute value will be, so this one is going to be x around -1. Okay, so you are having x around -1. Absolute value of x, okay, absolute value of x turn out to be what? Turn out to be because you are having x around -1, so you have x less than 0. Okay, according to this picture, you see that x is around -1 on both sides like this, and you are having x less than 0. Okay, so they are less than 0, so x smaller than 0 for sure. Okay, so in this case, you're going to be able to conclude that absolute value of x turned out to be -x. Okay, so absolute value of x turned out to be -x. And you are also having absolute value of x plus 1 turn out to be x plus 1 if, okay, x plus 1 is more than 0, and it's going to be negative of x plus 1 if x plus 1 less than 0. So in this case, you are in the yellow area. So you are in the x plus 1 less than 0, and you are having x plus 1 more than 0. Okay, so you have absolute, and it's going to be x plus 1 and negative x plus 1 in these two cases. Okay, so we're gonna have your function. So your function turned out to be, let me copy the whole thing here. Okay, so you're gonna take the screenshot like this, copy. Okay, so you're gonna see that this guy turned out to be equal to, okay, so it's gonna turn out to be absolute value of x turned out to be -x. Okay, the other term will be just copy down -2. Okay, and you are in the blue case, so you have x plus 1 if x more than -1. So you are in the blue case here. Okay, and you are having -x plus x squared minus 2 over minus x plus 1 if x less than -1. And this one is the yellow case. Okay, so this guy you'll be able to factor into two parentheses. So this guy will be x plus 1, x minus 2 if x more than -1. Okay, it is quadratic function, so it's going to be just factor in this way. and you have x plus 1, x minus 2 over x plus 1 if you have x less than negative 1. And so you just get rid of this guy and this guy, this guy. I forgot negative sign. So it's gonna be negative sign. Okay, negative sign. So in this case, you would get x minus 2 if x more than negative 1, and you get negative x minus 2 if x less than negative 1. And this one is the yellow case, and this one is the blue case. Okay. And so we're gonna compute the left and right limit. So limit x go to 1, not go to 1, go to negative 1, okay, from the left of this guy. Okay, so I paste this one like this, will be equal to limit x go to negative 1 from the left, and you are in the yellow case, so it's going to be negative x minus 2, and this one turned out to be negative, and you have negative 1 minus 2 equal to 3. Okay, and let me make this one a little bit smaller. So you have limit x go to negative 1 from the left. Okay, and now you're gonna compute limit x go to negative 1 from the right side. Okay, so you paste same thing. So you see that this guy will be in the blue case. So this guy will be limit x go to 1 from, not 1, negative 1 from the right of x minus 2. Okay, and this guy you have negative, negative 1 minus 2, so it's going to be negative 3. Okay, and this guy are not the same. Okay, so this guy are not the same. So you have limit x go to 1 from the left not equal to limit x go to 1 from the right side. So we're gonna conclude that limit x go to negative 1 of the question does not exist. Okay, so we're gonna conclude here that okay, so we're gonna conclude here that limit x go to 1 or to negative 1 of the function does not exist. Okay, so this is how we conclude everything. Okay, so this one you first simplify, okay, left limit, right limit, and you're gonna have the right side equal to x minus 2 and the left side equal to negative x minus 2. Okay, and you have the limit does not exist because the limit from the left side equal to 3 and the limit from the right side equal to negative t. Okay, so this is how we obtain the final answer. So we done with the left limit and right limit. The next thing that we're gonna study is called the sandwich or squeeze theorem. The sandwich or squeeze theorem, you have f be a function such that you have the function f, which is the middle function, lie between two functions called g and called h. Okay, around x equal to a. If you have limit x go to a of gx equal to L and limit x go to a of hx equal to L as well, you'll be able to squeeze the limit x go to a of fx to be equal to L also. It's going to be in this picture that you have your function fx in the middle, you have hx on top, you have gx on the bottom. Okay, so you have fx, gx, fx between hx and gx, and you see that the limit x go to a of hx turn out to be equal to L from both sides. Limit x go to a of gx turn out to be equal to L on both sides. And the picture you see that it look like sandwich. So you have bread here, you have bread here, and you have the meat here or the ham in the middle. Okay, so this one may be the ham one. Okay, and this one is your bread. Okay, so you see that this sometimes called the squeeze theorem. It's not left right, it's gonna be the top function and the bottom function. If you have the middle function and the top function and the the bottom function give you the same limit, you're gonna be able to conclude that the limit of the middle guy turn out to be the same as well. Okay. For example, if you have fx, okay, if you have fx is a middle function, lies between the yellow one, which is 1 plus x squared plus x over 2, and gx equal, and the top function equal to 3x squared minus x. Okay, so in this case, you're gonna use the squeeze theorem to determine limit x go to 1 of fx. In order to obtain limit x go to 1, we compute limit x go to 1 of the yellow guy. So it's going to be 1 plus x squared plus x over 2. So this guy will be 1 plus 1 squared plus 1 over 2. Okay. And this guy will be 2. Okay. So this one is the limit of the yellow guy. Let me resize this one a little bit. Okay. My So I don't know what to do. Let me uh, let me recite this one a little bit. Okay, and move it here. Okay, so you compute the limit of the yellow function. And the next one will be you compute the limit of the blue function. So you have limit x go to 1 of 3x squared minus x. So this guy will be 3 times 1 square minus 1. So it would give you 2 as well. So you see that the limit of the yellow function, okay, is equal to 2, and the limit of the blue function also equal to 2 in this case. It's not left right because this value fx is for y. Okay, do not confuse, this one is not for x, it's going to be y. And you see that this one means that you have the yellow one Okay, so you have the yellow one down here, the blue one up here, and your function is the middle one, and you see that this one is along the y-axis, not the x-axis. Why do I need to emphasize on something like this? Because most of you confuse that, hey, this one is left, this one is right, okay? However, when you are doing squeeze theorem, it's not left, right, it's gonna be squeeze top, bottom, like this, okay? And you have this equal to 2, and you're gonna conclude by squeeze theorem. We can conclude that the limit of the middle guy also equal to 2, okay? It's not left equal to right. You see, we not see negative, positive here, okay? So by squeeze theorem, we have limit x go to 1 of fx turned out to be equal to 2. The next one, you like to find limit x go to 0 of x squared sine 1 over x. Okay, so for this function, it's not gonna tell you how to use squeeze theorem. You're gonna have to think about the squeeze theorem by yourself. You're gonna have to see first that what you have. The thing that you are having turn out to be psi function. And the psi function that you are having here, okay, so the psi function that you are having here turned out to be sine 1 over x. And when you have sine 1 over x go to 0, sine 1 over x is undefined, and you're not allowed to cancel with another x outside sine. So you'll not be able to cancel x squared with x. It not happen that way. Okay? So in this case, the thing that you may use from your high school turned out to be, you're gonna know that sine 1 over x lies between negative 1 and 1. Okay, so you know that your sine 1 over x must lie between negative 1 and 1. So this one is the middle guy. And the question asks you about x squared sine 1 over x. So you're gonna multiply x squared both sides. So you get negative x squared. Okay, so you get negative x squared less than or equal to x squared sine 1 over x. Okay, and this guy less than or equal to x squared. Okay, so you multiply x squared to the whole equation, and this is what you get. And you see that this one will give you the bottom function, the yellow function, and this guy will give you the top function. And the ham that we are having for sandwich theorem turned out to be the middle function, is the function that we are looking for the limit. So you're gonna compute the limit of the yellow guy. So the limit x go to 0 of negative x squared equal to negative 0 squared equal to 0. And the limit x go to 0 of x squared equal to 0 squared equal to 0. Okay, so you have the limit of the yellow guy, and you have the limit of the blue guy here. So we be able to conclude by squeeze theorem. Okay, so by squeeze theorem, we have the limit of the middle guy turned out to be equal to 0. So let me conclude these two examples a little bit. For the first example, it gives you explicitly that you have fx lie between two functions, and you're gonna compute the limit of the top function and the limit of the bottom function. The limit of the top function turned out to be 2. The limit of the bottom function turned out to be 2 as well. So you'll be able to squeeze the value of the limit of the middle function to be 2. Similarly, for the second guy, this one is a little bit more difficult because it's not give you the top or the bottom function yet. However, you may have to recall the property of the sine. Sine 1 over x will lie between negative 1 and 1, and you're gonna multiply both sides by x squared. So you get negative x squared less than or equal to x squared sine 1 over x less than or equal to x squared. So you're gonna compute limit x go to 0 of negative x squared. So it's gonna be equal to 0, and you're gonna compute limit x go to 0 of x squared. So it's gonna be equal to 0 as well. So you see that you have the bottom function equal to 0, you have the top function equal to 0. So by squeeze theorem, it allow you to conclude that limit of the middle guy, which is x squared. Sorry, I forgot my square here. X squared sine 1 over x turned out to be equal to 0. So I will give you the final remark on this one. For the conclusion here, we may conclude the techniques for finding the limit of a function as follows. Okay, so in this case, you're gonna be able to use graph. You're gonna plug in simplify. You're gonna use left right limit, or you're gonna use squeeze theorem. Okay, so this one is gonna be page so 29 to what 29 to 32. Okay, 29 to 32, 29 to 32. And this one, I think I forgot ing for finding the limit of a function. And plug in simplify. Okay, plug in simplify is gonna be the page 26 up to 28. Okay, 26 up to 28. 26 to 28, and this one is 33, not 33, 34, 34, and use graph is going to be on page 23. Okay, so this one is the conclusion that we did find the limit in 4 different ways. The first one using graph, the second one you're gonna plug in and simplify. Okay, so the plug in and simplify is gonna be quadratic. Okay, and you have square root a minus b multiply with square root a plus b equal to a minus b square, that you allow you to simplify square root. Okay, and for left right limit, it's gonna be 2 cases that you will use this one when you see absolute value and when you see piecewise function. Okay, and for squeeze theorem, it's gonna be the function that you're gonna see sine 1 over x. Okay, sine 1 over x, cosine 1 over x, something like this. Or you see fx lies between two functions, the yellow one and the blue one, as we have seen. Okay, and please also keep in mind that the limit of the function at x equal to a demonstrate that more than the value of the function. When you see the limit exists like this, okay, it's not gonna just demonstrate about the value of the function. What does it mean to be limit x go to 0 of x squared sine 1 over x equal to 0? Okay, so how could I say something like this here? Why did I say that? Okay, so please keep in mind something like this. The reason is because you see that you don't know the graph of this one. However, you be able to determine some behavior of this function. For example, you don't know about the graph of this guy. Okay, you don't know about the graph of this guy, but you know that at 0, the function will approach to 0 both sides. So it's gonna look like this. Okay, and you see that the value at 0 is undefined. Okay, so you have a hole at 0, but the left side and the right side of the function are okay. And you can see also that this function has problem only at x equal to 0. The other point are just 5. Okay, so you just have x squared sine 1 over x like this. Okay, so this one is called the conclusion, and the technique that we have for finding the limit turned out to be 4 techniques that we study. Okay, so this one is the technique in order to find limit x go to a. Okay, for finding limit x go to a of fx, it's gonna fall into these 4 cases. Okay, so it's gonna be case 1, case 2, case 3, and case 4. Okay, it's not going to be other cases. Another last technique that we're going to study is called L'Hopital. It's going to be number 5, but not right now. Okay, it's going to be just these 4 techniques at the beginning here. Okay, so that's all I think I like to cover for this lecture.